Ground procedures. Startup mission. Okay, everything checks out with the exterior inspection. In this mission, we'll learn to perform the internal inspection and the before, during, and after startup procedures. Once you gain fluency with these and understand the reason for each step, you'll be ready to taxi the airplane. It is important that you review the manual and understand the various systems of the airplane, or it will be difficult for you to understand everything that I'm going to explain to you here. In addition, I suggest that you have a knee board handy with written procedures so you can follow the checklist with me. Let's go. Interior inspection procedure. This cockpit preparation procedure is performed from left to right in a clockwise direction. So we'll start from the left console after first checking these 3 steps. Step 1. Ejection seat pins inserted. Step 2. Ejection sequence valve in the rear cabin is set as required. Now note that this is not a task for you. This occurs in the rear cabin. Step 3. Leg restraints, survival kit, harnesses, and pedals are adjusted. Once this is done, we'll make a clockwise scan and work our way through the following panels. Now on to the left console. Note the circuit breakers panel. Most of the aircraft's breakers or circuit breakers are in the circuit breakers panel. Circuit breakers, when heated due to excess current, pop out, isolating the circuit from the electrical system and leaving a white band visible. Pressing the breaker once it is cooled will reconnect the system. The breakers panel has labels to show what systems depend on each breaker and which bus they are connected to. I recommend that you know by heart the position of the breakers for at least the essential equipment connected to the main bus, as well as where the circuit breakers for the landing gear and trim are, so that in case of an emergency, you can locate them quickly. Step 4. Breakers, all in. Next, the emergency control unit. In an emergency, this is used to manage the aircraft's trim. We may also disconnect the hydraulic system assistance to control roll, or retract the speed brake in the event of hydraulic failure. Step 5. Check the emergency pitch trim guard. Ensure that it is in. This guard turns 90 degrees. When rotated 90 degrees, this both releases the emergency trim switch and opens the normal trim electrical circuit, preventing it from continuing to send faulty signals. Now note that if the trim tone breaker is in, the interaction between the air brake and trim electrical circuits is also switched off. Step 6. Ensure that the emergency trim breaker is in. This breaker protects the trimming electrical circuit, along with the main breaker in the breaker panel labeled COM pins. Step 7. The throttle. Check its full range of travel. Take it out of stop, advance it fully forward, then bring it back and leave it in stop. Now to the engine control panel. With this, we will control engine start and ignition. In addition, it will let us use GPU current. Step 8. Ensure that your ignition is set to off. Step 9. Ensure that the starter is normal. Step 10. Ensure that the GPU is on. We'll have a GPU connected to the airplane and ready to provide power later on when you press the Cori. A Cori is a button that acts as a switch, and to know whether it's connected or not, note the illuminated inscription. The name Cori comes from its creator, Boris Cori.
Chief, turn on the ground power.
Copy. Ground power is now on.
Now on to the fuel panel. This allows us to manage the airplane's fuel. Step 11. Check the pumps in the front cabin and ensure they are set to off. Now this completes our inspection of the left console. Now on to the left panel. Step 12, landing lights, in. Step 13, Stall warning. On. Step 14. Parking brake. Set. Now on to the central console. Step 15. Accelerometer reset to 1G. Step 16. UHF radio to off. Step 17. UHF antennas to OTT. The UHF radio has two antennas above and below the fuselage. These antennas are also shared with the IFF equipment. Step 18. Tarsyn in compass mode. This allows synchronizing the gyroscopic indication with the magnetic flux valve in the right wing. Step 19. Set the altimeter to the airfield elevation. It will be adjusted later with QNH. Step 20. Set the clock. Now notice it's mechanical, not an electrical clock. Step 21. Emergency horizon locked. Step 22. IFF off. Now let's move to the right panel. Check that the electrical system is disconnected in the following manner. Step 23. The inverter set to off. The inverter converts DC into AC for equipment like the Tarsyn or navigation systems. Step 24. Ensure that the generator is set to off. The generator is the primary source of electrical power and is driven by the engine while it's running. Step 25. DC bus tie off. The current distribution is done through two main buses, a primary and a secondary. put it another way, each bus is simply a line that provides power to a group of equipment. Leaving the switch off ensures that the primary and secondary bus will be disconnected from each other. Step 26. Batteries off. The two batteries are a secondary source of energy, especially when the aircraft is not powered by the generator or the GPU, either while on the ground before start or due to an engine stop in flight. In the latter case, the batteries would normally provide enough power for about 30 minutes after turning off all non-essential equipment. Next, let's flow to the right console. Now check out the oxygen panel. Step 27. The cabin altimeter displaying the airfield elevation. Once the airplane is pressurized and once we have connected the air conditioning system and are above 8,000 feet during flight, it should keep showing a cabin altitude of 8,000 feet as we climb until the aircraft reaches about 20,000 feet. Above that altitude, if we go on climbing, the system is no longer able to maintain a cabin altitude of 8,000 feet because the pressure difference between the outside and interior is too high. Let's go to the lighting panel. The lighting panel allows us to control both interior and exterior lighting. Step 28. Ensure that the interior lighting is set to off. Step 29. Position light to bright. Now these are the wingtip green and red lights. A white light in the tail and two white silhouette lights. Step 30. Anti-collision light on. This light flashes red on the top of the plane's tail. Let's move to the VOR ILS MB control panel. From this panel we can tune VOR or ILS frequencies to receive from the appropriate beacons. Step 31. VOR off. Next, we'll look at the TACAN control panel. We can receive signals from both TACAN stations on the ground and from other aircraft using the air-to-air mode. Step 32, TACAN off. Step 33, oxygen valve lever, open. Now I hope you've connected the oxygen lever as soon as you've put your mask on or you won't be able to breathe. The plane has 4 oxygen bottles, 2 in the nose and 2 under the rear cabin seat, offering a total amount of 8.4 liters. Their pressure is 1800 psi, which is checked during the outside inspection. Now let's look at the VHF control panel. Step 34. VHF off. The VHF enables communication in the frequency range from 116 to 149.975 megahertz. Yeah, I've looked in the manual. Its main elements are a transceiver, the control unit itself, and the antenna. Step 35, the oxygen failure warning switch. Now these are both to be on. Now however, this switch is located in the rear cabin, so there's no need for you to do anything. But you should know, the system provides a warning in the event that pressure drops below 45 psi in any of the cabins. Now let's go to the intercom and audio control panel. Step 36. At the intercom, pull the potentiometers. In normal flight, we'll have raised at least the rotaries for the INT, UHF, VHF, hot mic, and hot mic talk. This means that we can listen to communications between the cockpits and with the radio equipment. Once raised, we'll adjust the volume by turning the rotary. We'll also leave the 6th position selector, commonly known as the biscuit, in either VHF or UHF, depending upon the radio we want our voice to be transmitted through. You'll probably eventually make a mistake and transmit through the wrong radio. That's called a galipazo, a slap. Everyone does it.